Hi, everyone. Right now, we're going to talk about why the patterns that you saw in density, pressure, and temperature occur. So in your lab, you notice that density, pressure, and temperature change in certain ways as you move upwards in the atmosphere. What we're going to do now is explain why you see those patterns that you saw. We're going to start with a density review. So you may or may not remember from our chemistry unit and before that density is equal to mass divided by volume. And in these two gas samples, we have been given our mass and our volume. And here we have mass and volume. So we're really just going to be doing some plugging in. So for sample A, my mass is 60 grams and my volume is 30 milliliters. If I divide those, that tells me that the density of this gas is 2 grams per milliliter. For sample B, my mass is 100 grams and my volume is 10 milliliters. And so that tells me that the density of sample B is 10 grams per milliliter. So we have 10 and 2. 10 is larger than 2. So sample B is more dense than sample A. And sample B is more dense than sample A because you'll notice there is less volume. So we had 10 milliliters versus 30. So sample B has less volume, which just means less space. So there's less volume or space. And in that smaller space, we're actually trying to fit more stuff. So there's 100 grams of stuff in this sample versus just 60 grams of stuff in that sample. So we have more stuff and less place to put it. So more mass slash stuff in less volume slash space. So if we look at that, we're going to have a smaller area with a lot of particles packed in. When particles are packed, they're close together, and density is a measure of how tightly packed or close together something is. So these are tightly packed and close together. On the other hand, here we have a less dense sample. And the reason the sample is less dense, like I said, is because we have more volume, 30 milliliters versus 10. So we have more space. And in all that space, we're trying to fit less stuff because now we only have 60 grams of stuff where we had 100 before. So now there is more space and less stuff. So if we look at that, we're going to have a larger area and less dots. And when there's more space and less dots, those dots can be more spread out. So these are loosely packed and more spread out. Okay, so let's apply this to the different layers of the atmosphere. So here I have a very basic drawing that is not to scale of the different layers of the atmosphere. If I were to color these in, so let's make the troposphere is going to be green. So we have our green troposphere. Troposphere is closest to Earth. And notice that the circle that surrounds the troposphere is actually the smallest circle of the 4. And that's important, okay? And then we see the stratosphere, where there's actually more yellow going in here than there was green in the last part, because the circle is now bigger. And then I move to the mesosphere, circle's even bigger. There's more blue going in here than there was yellow or green. And then I'll make the thermosphere red, which is the biggest circle. And you can see I'm using a lot of red ink. If this was real ink, then I did any other color, okay? So the circles that surround, let's find a nice bright color that will stand out. So the circles that surround each layer get bigger and bigger. So that circle is a little bit bigger than Earth. This circle is even bigger than the layer before it. This circle is even bigger than the one before that. And then as there wouldn't really be a line here, we'd more just be like drifting off into space, but that's the biggest circle. And so all of these circles get bigger, meaning there's more space. There's more red on this diagram than there is green, yellow, or blue. So as you increase, let's make this less big. So as you increase altitude, which is what this question is asking, so as we increase altitude, which means we're moving away from the surface of Earth, the volume of each layer increases. Okay, so this red area has more volume. Should actually make that red. So this red area has more volume. And this green area has less volume. So as you move out, there is more space because volume is just a measure of space. So as we move out, we get more space. Now, our next question, putting together the pieces of this, asks, how does the number of gas molecules of each layer in the atmosphere change as you increase in altitude? So we're still looking at an increase in altitude, but this time we're looking at the number of gas molecules. Now, a fact that you might not know or realize is that 90% of the gases in the Earth's atmosphere are contained in the troposphere. And that makes sense because these are the gases that we breathe, the gases that plants need to grow. All those gases need to be close to the Earth because that's where things are using them. So 90%, almost all of the gas molecules that the whole atmosphere has are shoved into the troposphere. So that means that in this area that has the smallest volume, we are actually ending up with the most molecules packed in. So even though this has the least amount of space, 90% of all the gas molecules in the whole atmosphere are shoved into this tiny little part of the atmosphere. Okay, so all these gas molecules are there. They're all packed very tightly. They're being used by organisms. They're being exchanged. They're all packed there. And as you move out in the layers, you get even less and less gas molecules. So there's going to be a little bit less in the stratosphere. And then there's going to be even less in the mesosphere. And then there's very, very few gas molecules in the thermosphere because at this point we're almost in space. And we know that the space in space is not air. The space in space is empty space. Do you think I said space enough times in that? But that's why it's called space, because it's just empty space. It's a vacuum. Okay. So as you increase in altitude, the number of gas molecules, also known as mass, because it's the molecules that have mass, decreases, and it decreases very significantly. So just to recap, as we're moving up in the atmosphere, we're gaining more and more space, but we're getting less and less stuff. Okay, and that should give you a hint as to where this is headed. So why is the troposphere more dense than the thermosphere? Let's compare those two layers of the atmosphere. So troposphere is the closest layer to Earth, and then the thermosphere is the farthest. Okay, the troposphere, if you look up here, has the least volume, has the least amount of space. On the other hand, the thermosphere actually has the most volume and the most amount of space. This is the biggest layer as far as volume goes. So that takes care of volume, but what about stuff? Now, remember I just told you that the thermosphere contains, or the troposphere contains 90% of all the gases in the atmosphere. So that's a lot of stuff. So the troposphere has the most stuff, which means it also has the most mass. On the other hand, the troposphere, the thermosphere, like we just said, is really close to outer space. We're getting into that area where it's a vacuum, it's empty space, it's not air anymore, really. So this is going to have the least stuff and the least mass. So what happens when we have a small volume and a lot of mass? So small volume So low volume, high mass means lots of stuff in a tiny amount of space. On the other hand, in the thermosphere, we have the most volume, lots and lots of space, but a very small mass. So the thermosphere is going to give us high volume, low mass, meaning we have a giant area and only a few particles. That tells me that the troposphere, which corresponds to all of this, is going to have high density. But the thermosphere, which corresponds to this one, is going to have very low density. Because in the troposphere, all the stuff is very, very tightly packed. In the thermosphere, lots of space, not a lot of stuff. The stuff is very spread out. Okay? And you saw that in your lab. As you moved away from the Earth's surface, the atmosphere became less dense. Okay? So let's apply that to pressure. So pressure happens, air pressure happens when gas molecules collide. When they collide, they create a force, and that force acts as the pressure. So in somewhere like the troposphere, we know that the molecules are very, very, very dense. So they're very, very, very tightly packed. We also know that these are still gas molecules, and gas molecules have a lot of energy. They're moving very quickly. They're bouncing off each other. They have a lot of energy and movement. So all of these pieces are constantly moving, colliding, creating pressure. In the thermosphere, there's less molecules in a greater amount of space, meaning they're less dense, they're more spread out, but they are still moving. They're still gases. They still have a lot of energy, they're moving, colliding. Now, if you are a blue molecule over here in the troposphere, you're a blue molecule in this cylinder, and you're moving around like crazy with all these other molecules around you, are you more likely or less likely to collide? The answer is more likely. So in the troposphere, there are more collisions between molecules, which leads to higher pressure, because pressure is just the collision of molecules. In the thermosphere, you are less likely. If you're one of these molecules, you have all this space to move around. There's no one near you. You can hang out, you can move side to side and not touch anything. So there's going to be less collisions in the thermosphere because of the smaller density, which is going to lead to decreased pressure. Okay, so as you move up in the atmosphere, the pressure is going to go down, which is another pattern you saw in your lab. Okay, now I also mentioned that temperature has to stay the same. The reason for this is because when we add heat to molecules, they move faster. Molecules that move faster have more collisions. So if the thermosphere was a lot hotter than the troposphere, then the thermosphere might have higher pressure, because even though these are further apart, they could collide more if they're moving faster. And so we know that the troposphere has higher pressure than the thermosphere because in the troposphere, density is higher, meaning molecules are closer together and more likely to collide. In the thermosphere, molecules have more space, so there are less collisions. Hopefully this helped to explain some of those patterns that you saw, and hopefully you enjoyed this lesson.